Okay, so good morning to everyone. Now, today we will move discussing about the Tower of Hanoi problem. So, this is Tower of Hanoi problem is also an algorithm problem that is named as the Tower of Hanoi. Now, today we will see how to write the algorithm of Tower of Hanoi. How to write the algorithm of Tower of Hanoi by taking a small example as well as large example. So we will take both of it, small and large example with three disk. In the case of large example, we will use a three disk problem and let the problem is there. Like this is a problem you see. In this problem, there are three towers given. In a problem, you see this is a tower, this is also a tower, and this is also a tower that is given. And this in these three towers, one of the tower in between these three towers, one of the tower has the uh, stack of disk. One of the tower contains the stack of the disk. Means the disk are one by one, the disk are arranged there. So the stack of the disk, you see, this is a disk, this is a disk, then this is a disk, then this is a disk. So like this stack of the disk are present in a tower. Stack of the disk are present in a tower, and the disk which are arranged, the disk which are arranged in the order of decreasing order of the size from bottom towards up. That means the highest size disk will be in the bottom, then the next size disk will be up to that, then next, like this. That means that stack of disk, the stack of disk are arranged, the stack of disk are arranged in a decreasing order, the stack of disk are arranged in a decreasing order from bottom to top. That means the most length disk, the most length size disk will be in the below, then next, like this. The topmost disk, whichever the topmost disk is present, that topmost disk will be minimum size disk. The topmost disk will be of minimum size, the topmost disk. So like this they are arranged. Now our main working is we have to move all the disk like this. This is a tower A, this is the tower A, this is the tower B, and this is the tower C. Now our main working is we have to move all the disk that the way they are arranged. We have to move that all the disk one by one to the tower C. And at when we will move at that time, it should be in mind that the larger disk should not be kept over the smaller disk. That means the larger size disk will be always in the bottom, and the lowest size disk will be in the top. So this should be keep in mind that the larger disk should not be kept over the smaller disk. The larger disk will be in the below, and in the larger disk, the above the larger disk, there will be the smaller disk present. So like this, the arrangement will go on. The arrangement will go on. So we have to move here the way these disks are present. In same way, we have to move the disk here. We have to move the disk here in the same way. So in the tower C, same way as the same way that is present in the tower A, same way the disk will also be present in the tower C. But let's say we have tried to move here. So that means the topmost disk will be moved first. So that means the smaller disk will came here. First, the smaller disk will came here. Then the next disk we will move here, let's say. So that means what? That means this is violating the rule, because the smaller disk, it is said that the larger disk should not be kept over the smaller disk. But if we try to move the disk like this from tower A to tower C, then what will happen? Then the smallest disk that will be came last. Then after that, the larger disk will be came over. If we want to move like this, so we will see that how we will move this disk one by one, and that's why we use this tower. This tower is known as the auxiliary tower. This tower is known as the auxiliary tower, and we use this auxiliary tower that we can use for transfer in the disk. We can transfer in the disk, and there can be any number of disks given in the tower. It doesn't mean that only the three disks will be present. The number of disks may be increased. Let's say that number of disks may be increased. It's up to that. But we have to move the disk from tower A to tower C in such a way that the larger disk will be presented over the larger disk. So that's why we will move the disk one by one. So this is the problem. So, and whenever the disk size will increase, that means the number of disks will be increased. That time we will use this auxiliary. We will use this auxiliary tower. So that's why we use this auxiliary tower. Now, there can be any number of disks. The number of disks can be any. There is not mentioned that this number of disks should be present. The number of the number of disks can be increased. So let's solve this problem by taking a small example. Okay, so first, in the first case, first we start with the solution for the single disk. With the solution for the single disk. Now, in the solution for the single disk, you see there are three towers present. 1, 2, 3. These three towers are present, and single disk is present. So that means in the tower A there is a disk present. So if we have to move this disk, to our destination, now A is the source. This A is our source tower. This A is our source, and this C is our destination. So we have to move the disk from source to destination. Now in this source, only one disk is present. So whenever there is only one disk present, then there is no, do not have to move it to the auxiliary tower, because there is only one disk present. So we can directly move it to the destination. So that's why you see we have written that directly move from tower A to tower C, because there is no such condition arises that the larger disk is placed over the smaller disk. Like this, no condition is arising. So that's why what we will do, that's why if there is only a single disk, if there is an only single disk present, then we will directly move it to the destination. There is no such condition we have to check. So this is the solution for the single disk in the case of single disk. Now, if let's say if we have two disks present, if there are two disks given, let's say in the case there are two disks given, so two disks are present. So what will happen if we have two disks? Now in the case of two disks, you see in the case of two disks, there is 1 and 2. Now 1 number disk, it is the larger disk, and over the second disk is placed over this number 1 disk. Now number 1 disk is the larger disk and number 2 disk is the smaller disk. Now that is, I said that here this order that disk will be arranged, that the larger disk will be in below, and over the larger disk there will be the smaller disk present. So that means 1 is the larger disk, so it is placed, and over 1 there is the smaller disk. Number 2, this is the smaller disk, this is presented here. Now what we have to do, we have to move this disk, this two disk, to the tower C, because tower C is our destination. So we have to move these two disks into the tower C. So how we will perform now? Now if you see, if we directly move two number of disks to the tower C, then in that case what will happen, that will be moved first, and after that one will be moved. That means what? That means it is violating the rule because the smaller disk is in below, because number 2 is the smaller disk. So smaller disk in below and one is the larger disk and one is presented over, or you can say placed over the number 2 disk. That means this condition is violating the rule. So we cannot take that. So what we will do now? What we will do now? We will use the auxiliary tower. Now we will use the auxiliary tower. So here, what will happen? We will move the two first into this auxiliary tower. So this two we have moved into the auxiliary tower, and this one we directly move into the destination. So that means here two will be present, and here now one is present. After that, in the second step, we will move the two here. So that means what happened? That means there is the way that the larger disk is placed below and the smaller disk are placed higher. So that's why this order will be maintained. That means this smaller disk, in case of two disks, for the smaller disk, we will move it into the auxiliary tower, and the larger disk we will move to the destination tower. And from after that, we will move the tower smaller disk from the auxiliary tower. So this is the way if we have two disks. So that is written, see, that's the way it is written, that moving a disk from tower A to tower B. So from tower A to tower B, we'll move using the C, and then move a disk from tower A to C, and after that we will move the disk from tower B to tower C using A. So this is the way if we use the two disk. Now let's say if we have three disk, if we have three disks present, let's say if we have three disks present, in that case, what we will do if we have three disks? Now here you see in the tower A, all the three disks are present. So one number disk is the largest, then the second number disk, then the third number disk. So that's why from larger to smaller, it is arranged from bottom to top. The larger to smaller, it is arranged, the disks are arranged. Now what we have to do? We will do here, so see what we will do, move two disks from A to B using C. So that means this, in this auxiliary tower, we will move this 3 and 2 disk. Now you can say that that means what? That means 3 will came first, because whenever we have to move 3 is on the top, so that means this disk will be first you will use. So 3 will came, and over that then again 2 will came. So this is the first step, that move two disks from A to B using C. So that means 3 will came first, and over there 2 is came. So that means you can say that this is the violating the rule. But in the case of auxiliary tower, we didn't check that, because this rule we check only in the source and destination tower. In this auxiliary, this is the temporary tower we are using. To transferring this, we are using this temporary tower. So that's why in this case, if the rule violates, then also there is no problem. So that's why the smaller disk, you see the 3 is the smaller disk. So 3 is placed, and over the 3, the 2 second number disk is placed. But the second number disk is what? The second number disk is larger. But in case of auxiliary tower, we didn't consider our this in the auxiliary case. In the case of auxiliary tower, we didn't consider this rule. Only for the source and destination, we will check that source and destination tower. So now 3 and 2 are moved. So what we will do? We will move 1 now. We will move 1 now. So that's why in the second step, it is C, that move a disk from A to C. That means this one number of disk is left. So this one number of disk will be moved to the our destination tower, this one number of disk, we will move our destination tower. So from A to C, this one number of disk is moved. And now after that, the disk, these two disks are present in the auxiliary tower. Now this two disk from B to C,
Hello.
okay,
Sir, your voice is not clear.
my voice is not coming.
Yes, sir.
Now it is audible.
Yes, sir. Now it is audible.
Okay, okay. So the main thing we are saying that now what will happen? So for in case of is, I will repeat that. I will repeat this again.
Yes, sir. Yes.
Okay, okay. So that means what you see from this is the three towers. Now for our, we will see the solution for three disks. We will see the solution for the three disks. Now for the solution for three disk is what? The three disk will be present in the our source tower. The three disk will be present. Now in which way it will be placed? Now the larger disk will be placed first. So one is the larger disk, and over this the second disk, this is the next larger, so this is placed, and then over that three number of disk, number three disk is present, and this disk is the lowest. That means this is the size is the lowest, so that's why it is on the top. So now in this way the disk will be presented in the tower C. The destination, in this way, the destination tower will also be placed. That disk will move this disk one by one, and in destination tower, this way also the disk will be present. So now how we will do that? So how we will do that? Because now in this way, if we have to move this way, then this 3 and 2, this 3 and 2, first this 3 has to be moved to the tower B, then the 2 we have to move to the tower B. Okay. Now this is the auxiliary tower, and in this auxiliary tower there is no condition that the smaller disk will be in below, and the larger disk will be in below, and over there the smaller disk will be present. Like this, any such constant is not present for the case of auxiliary tower. But for the destination tower, it should be maintained, and then the source tower, it should also be maintained. But for auxiliary tower, there is no such condition. That's why you see that first we moved 3 here. First 3 disk, number 3 disk is moved. Now number 3 disk is the smallest. Number 3 disk is the smallest. So we move the number 3 disk first, and after that then we move the number 2 disk. So over the smaller disk, the larger disk is present in the auxiliary tower. But in the I have said that in the auxiliary tower, these rules are not applicable. We didn't see that rules. So that's why we can place the disk like this order also in the auxiliary tower. Now, after these two disks are moved, what we will do? We will move this number one disk into this tower, in that destination tower first. So number one disk is moved. After moving the number one disk, what we will do? After moving the number one disk, we will move our second disk from here, and after that third disk we will move here. So that's the order. That's the, if this order we maintain, then the same order which is in the tower A, in same way it will be present in the tower C also. This is the problem of Tower of Hanoi. The Tower of Hanoi is we have to move the disk. Main our motto is we have to move the disk from the source tower to the destination tower. But when we will move, then we have to keep in mind that the larger disk that is present will be in the below, and over that the smaller disk will be present. In that way, here you see the order that the larger disk is present, over it's the next large, and over it's the smallest. Same way here also, in the destination also, the same way it will be presented. And for that, maintaining the same way, we have to use this auxiliary tower. For some cases, we have to use the auxiliary tower, because if the single disk is present, there is no problem. We directly move that disk. But when the number of disks increases, that means over 2, 3, whenever the number of disks will be increased, in that time, this problem happens. In that cases, this problem happens. That means we have to maintain the auxiliary tower. We have to maintain this auxiliary tower here. समझ में आया?
Yes, sir.
Yes, sir.
So this is the solution for the moving of the disk. Now, if we move, let's say from this, if we move n number of disks, then what will happen? If we move n number of disks, now it is a solution for 3 disks. So in case of 3, if we place n, let's say if we place n, that the solution for n disk. That means in the case of, if we see these steps, first move 2 disks from A to B using C. That means if we use n, then means it is 3 and it is 2. That means if we use n, it will be n minus 1. That means the solution for the n disk will be move n minus 1 disk from A to B using C. Because here in the case we are seeing for the 3 disks, that if it is 3, then 2 disks are moved from A to B. That means if the n disks are present, then move n minus 1 disk from A to B using C. Then next step, move a disk from A to C. That is same, move a disk from A to C. And after that, next statement is what? Next step is what? Move 2 disks from B to C using A. That means for case of n, it will happen, move n minus 1 disk from B to C using A. So in case of 3, if we put n here, then it will be n minus 1. Then it will be n minus 1, and it will also be n minus 1, because for 3 it is showing 2. That means for n it will be n minus 1. So same steps will be present, only here we will put n minus 1. That is move n minus 1 disk from A to B using C, then move a disk from A to C, and move n minus 1 disk from B to C using A. So this will be the solution for n number of disks. So this is the solution for n number of disks. Now this Tower of Hanoi problem, is in the exponential increasing algorithm. If the number of disks increases, then it will become more complex. You see, whenever there is a single disk present, then there is only one step we are performing. But whenever the 3 disks present, then the permutation combinations ways we are doing that. First, move the disk to the auxiliary tower. Then a disk is moved to the destination tower, and then the disk that is present in the auxiliary tower are moved to the destination tower. So that means what? Whenever the number of disk increases, in that time the solution become more complex, or the number of steps will be increased. So that means this algorithm is of the exponential time algorithm. This algorithm, if we perform this algorithm, it will be exponential time taken algorithm. That means its complexity will be order of 2 to the power n. It will be exponential time taken algorithm. So that's why its time complexity will be order of 2 to the power n. Okay, till now it is clear.
Yes, sir.
Okay. अभिजीत,
Yes.
अभिजीत, ऋतिक, समझ में आया? Okay. So this is the way. Now we will see the algorithm of this Tower of Hanoi problem. And using this algorithm, Tower of Hanoi problem, we will see first the algorithm, and after this algorithm, we will trace the tree here. So first we will see the algorithm now. That what the Tower of Hanoi algorithm say. So first we will see the Tower of Hanoi algorithm. Now, this is the function name that void TOH, that means void Tower of Hanoi functions, and this function is taking 4 argument. This function is taking 4 argument, and this n is the number of disk. This n is, you see, this n is the number of disk, and int a is the it is the source tower. B is the auxiliary tower. This is the auxiliary tower. And C is the destination tower. So for the function for void Tower of Hanoi, we are taking 4 parameters N, A, B, C, where N is our number of disk, A is the source tower, B is the auxiliary tower, and C is the destination tower. Now, when will this condition run? If n greater than equal to 0? That means the number of tower is greater than 0. Because if there is no tower, then the Tower of Hanoi problem will not occur. So that means the number of towers should be more than 0. That means that's why it is said that if n greater than equal to 0, if the n greater than equal to 0, then you see we are calling this functions, we are calling this function recursively. We are calling this function recursively. That means what in the step, if we compare the first step, what we are doing in the first step, if there is the n number of solution for the n disk, that is for the first step, we are moving n minus 1 disk from A to B, from A to B using C. This is the first step. So this is written here. The same thing is written here using the recursive function, that in the first step, we are moving that Tower of Hanoi, this function, this is recursive function. This is calling again that n minus 1. You see n minus 1, we are moving, and here from A to B, that means move n minus 1 disk. This is moving, we are moving n minus 1 disk from A to B, because A is now our destination source and B is our destination now. So from A to B, we are moving using C. So this is the first thing, first operations we are performing. Then what we are doing, then we are doing in the next step. In the next step, we see that what in the next step we are doing from A to B. If we say from move a disk from A to C, that's why it is printing the value. You see, that is the next step. The value is printed because we will move the disk from A to C. And after that, in the next step, this is the, again, this is recursively calling. And now we are moving n minus 1 disk, from B to C using A. So this is the same thing, the same way it is written. It is the steps, it is written here. We are calling the functions in this same way. We are calling the functions in the same way. So this is the our algorithm. Okay, so that means what in this algorithm, first step, this is the Tower of Hanoi problem, and we are moving n minus 1 disk. We are moving in the first step, we already seen in the step 1 that we are moving n minus 1 disk from A to B. From A to B, we are moving using C. So using C, we are moving. The next step, move a disk from A to C. This is the next step. And in the third step, we are again moving n minus 1 disk from B to C using A. The same steps we are written the same. This is the purely in the English language we have written, and this is the algorithm way that we write that. Okay, so in this way we write. Now if we try to trace the tree, if we, let's say, if we try to use this trace the tree, then let's say take an example. Let's say taking an example that here 3 is present, and for a value it is 1, it is 2, and it is 3, because 3 disks are present. For 3 disks, and one number of tower is A, second tower is B, and third tower is 3. Tower of Hanoi, and it is 3 1 2 3 we are giving. Now what will happen? This will go if greater than equal to 0. Yes, because n value is 3. So that means tower of Hanoi, it will be 3 minus 1. That means 2. Here 1 3 2. You see tower of Hanoi, this function is recursively called again. Tower of Hanoi 2 1 3 2. And A and C will be printed. Now A and C is what? 1 and 3. A and C is 1 and 3. So it will printed 1 and C. And then next, tower of Hanoi, n minus 1, B, A, comma, C. So it will be 2, B is what? 2, A is what? 1, and C is of 3. So this will be called tower of Hanoi 2213. Now this will be recursively called again. This will be recursively called. So that means now in this case it is become 2. For A it becomes 1. For B it becomes 3, and for C it becomes 2 now. So again, n equal to 0, yes, 2 greater than equal to 0. So this will be recursively called again. So 2 minus 1, it will become 1 now. So the value will become 1. Now A value is what? A value is 1. C value is 2. B value is 3. So it will be Tower of Hanoi 1 2 1 comma 1 comma 2 comma 3. Then A and C will be printed. Now for A and C, what is the value? 1 and 2. So that's why this 1 and 2 is printed. And now this will be what? This will be n minus 1 will become 2 now. And A is B is what? B is 3. B becomes 2 minus 1, it will become 1 now. So for B, it will be B will be 3, A is what? 1, and C is 2. So this will become 1312 now. This will become 1312 now. The next what will happen in the case of this, same as that for here also, like this for Tower of Hanoi 2213, it will become Tower of Hanoi 1231. That means if we put the values here, this is the way that if we put the values here, then after this the tracing tree will like this, the tracing tree will become like that. The tracing tree will become looks like that. Now whatever the values we get, that here from 1 to 3 the value we get, then 1 to 2 this, then from 1 to 3 3 to 2 this value we get, from 3 to 2, and then 1 to 3 this value we get, then 2 to 1 this is the another value we get, from 2 to 3 this is the value we get, from 1 to 3 this is the value we get. So that means if this is the steps, that if we perform these steps, if we perform these steps, and then in the 3 towers, from the 3 discs that is placed in the tower, if we perform like this, then it will be moved. The tower in the from the tower, the values will be moved. So first from 1 to 3, that means the disc first we have to move from 1 to 3, then the second disc we have to move from 1 to 2, then from 3 to 2 the disc we will move, then from 1 to 3 we will move the disk, then from 2 to 1 we will move the disk, and from 2 to 3 we will move the disk, and after that last step we will again move the disk from 1 to 3. So if we move, this is the steps, that if we use these steps, then the three disks we see, the three disks will be moved in from tower A to tower C in the same order from source to destination. So this is the tracing tree, and this is the algorithm of the Tower of Hanoi problem. Okay, clear?
Yes, sir.
Yes, sir.
और बाकी सबका समझ में आया?
Yes, sir.
Yes, sir.
Okay. So this is all about our Tower of Hanoi problem. So this is basically in the algorithm, the Tower of Hanoi problem. Sometimes it is given. So if you didn't remember to write the algorithm, then the steps like this, the steps you will write. If you didn't able to write this algorithm, if you didn't able to write this order, then simply write in the English for the solution of n disk. Simply write this way. For step 1, move n minus 1 disk from A to B using C, then move a disk from A to C, and then move the n minus 1 disk from B to C. Like this, simply write. There is no such rules. So if you didn't able to remember the algorithm, then there is no problem. Using the simple, write this. Using simply, you will write this algorithm. For by using the steps, you will simply write this. Okay. So then, if anyone has any questions, ask, or I will end the session.